All countries are facing a serious threat to the global climate change issue. Net zero emission becomes the globally essential target, mainly to avoid warming higher than 2 degrees Celsius and to limit global temperature rise to a minimum of 1.5 degrees Celsius. As a country that ratified an international mandate, Indonesia has participated in the climate issue through nationally determined contribution by reducing greenhouse gas emission. Recently, Indonesia has updated its NDC target to 32% with business-as-usual mechanism and 43.2% with international volunteers. It means that Indonesia put more ambition into the climate issue, leading to extraordinary actions. One significant sector for greenhouse gas emission is the oil and gas sector through the emission produced by the offshore oil platform. The data shows that one offshore oil platform can produce a carbon footprint of 1,232 kg carbon dioxide, equivalent per gigajoule, in consequence of utilizing diesel generation. The bad news is that around 500 offshore platforms are operating for ONG exploration in Indonesia, indicating that this infrastructure contributes significantly to carbonization. Moreover, the other essential problem in this sector, when the exploitation process has reached the maximum point, the offshore platform will be unoperated. The existing solution to this is demolishing the infrastructure. However, according to the data, this solution is not efficient and effective since there are approximately 100 unoperated platforms in Indonesia, and the government requires 10 trillion rupiahs to demolish them. If we have a look to the offshore ONG platform and offshore substation, they have a similar infrastructure with an offshore substation, so it's an opportunity to create an idea of integrating the substation and the oil platform on the same platform. However, to combine these two infrastructure, the sea with massive ONG potential and renewable energy source is needed. From the literature study, the conventional working area of the Timor Sea is suitable for this idea. Therefore, we, our team from Hasanuddin University, proudly present implementation of hybrid wind turbine and integration of HVDC systems on oil platforms in the Timor Sea region. In this research, we begin with a literature study using several previous studies on the topic. After that, relevant and accurate data is collected and will be analyzed in two ways, namely empirical analysis and theoretical analysis, which raises ideas. We choose the Timor Sea as our research solution for several reasons. The potential for renewable energy in the Timor Sea is high, such as wind energy with a speed of 6.5 meters per second and wave energy with a height of 2.4 till 2.6 meters. The existence of natural gas in this location, which 5.39 trillion square feet and has potential market value of up to 15 billion US dollar. There are two conventional oil and gas working areas with exploitation status, named Offshore Timor Sea 1 block and the West Timor block. To implement offshore wind turbines, offshore substation is needed to transmit the electricity. Here is the substation layout design, consisting of lower and upper decks on the platform. Regarding offshore wind turbines, Heliadiacs will be utilized with a cutting speed of 3 meters per second, 216 meters of height, 220 meters of rudder diameter, and 12 megawatt of power capacity. This model is suitable for Indonesia's wind characteristics, which are categorized at medium level. Moreover, the sea wave generator integrated at the bottom of the turbine in the form of two buoys can harvest up to 1 megawatt of electricity. Additionally, this platform utilizes a fixed jacket platform as the foundation for the platform. Here is the visualization of the ideal transmission line. As you can see, the slide's left side is Timor existing transmission line by the State Electricity Company, while the right side shows the proposed transmission line. To explain this comprehensively, we provide the visualization video. In this video, as you can see, the wind farm will be connected to the mainland grid through a Kupang substation located on the left side of Timor Island. In addition, the wind farm also will be connected to the oil platform substation. Consequently, the wind farm can transmit electricity to the oil platform and mainland grid, depending on the operator. Additionally, because we have integrated the substation into the oil platform, they can supply electricity from a platform to another platform. We utilize transparent experts to conduct the feasibility studies on projects related to energy use, ranging from energy potential, energy efficiency, to financial analysis. Using the Tabas software for the use of Heliad X 12 MW type wind turbines for 8 turbines, 96 MW, the total electricity exported to the grid is 248,655 MWh. Through this project, a total annual greenhouse gas reduction of 187,627.9 carbon dioxide per year was obtained, equivalent to 70,256.9 hectares of forest to absorb carbon. The SWOT analysis of this research is as shown on the screen, which consists of strengths, opportunity, weakness, and threats, and also SMART analysis, which consists of specific, measurable, accessible, realistic, and time-bound. In conclusion, through the realization of this idea, Indonesia can achieve the targets mandated by international regulation through achieving the nationally determined contribution, which will reduce greenhouse gas emission and also achieve the national target of a renewable energy mix of 23% in 2025. In addition, from a company perspective, the oil and gas industry can implement the ESG principle through the implementation of this initiative, especially in realizing green industry in the oil and gas industry.